Alright, what we have here is a March PX-250 with a upgraded Genesis control system on. We're going to go ahead and power up the system. Now it will take about 2 minutes for the control system to boot up. Okay, now you can see that the system is booted up. We are going to go to process setup and we'll write a recipe. We'll enable pre-process, and we want to put in a crossover pressure that where it'll pump down to before it starts the gases, and we'll put 200 millitorr for that. The purge duration is if you want to do cycle purges and how many cycles. We aren't going to be doing that now. Now we need step one needs to be enabled and without gases, and we need a settle time in there, and this is to get rid of any nitrogen that may have been in the chamber. We're going to do a 30-second settle time, and then our RF off, we want to put that to 1 second. That is for process look ahead. If you change gas flows from one step to the next, it allows time for the gas flows to change before RF comes on. We'll enable step 2, which will be our etch step, and we'll enable oxygen. We're going to put 350 SCCMs. That'll give us right around 1 torr process pressure. This will give around 20 seconds settle time. We're going to enable the RF generator, and we're going to do a set point at 200 watts. And then the RF on, we'll just put in 120 seconds or 2 minutes. And then again, we'll want to do a 1 second for the RF off. So now you can see we've written a recipe. We're going to pump down to 200 millitorr. We'll go to step 1 with no gases. We'll let it pump for another 30 seconds. And then step 2, we'll turn on oxygen for 350 SCCMs. Let that stabilize, settle for 20 seconds. RF will come on at 200 watts. We'll run a plasma for 2 minutes, and then we'll be ready to terminate it. So now what we're going to do is name this. So when we mount, it connects us to our USB. This is where we store recipes. And I'm going to name this test. We'll just call it test 1. Enter, and then we'll save, and then we can load, and now our recipe has been entered in on the USB thumb drive. Again, here you can see we can go to different recipes we have written before. We can load that. You can see the parameters change a little bit. So again, we can go back to test 1, and that's the recipe we just wrote. Now you can see we're almost down to our 200 millitorr crossover. Once we get to 200 millitorr, gases will come on. And we're flowing at our 75 SCCM set points for both our nitrogen MFC and oxygen MFC. Now down here, lower left corner, we can see we're in step 1. You can see the time that has elapsed. Again, we have 60 seconds stabilization time or settle time. Once that's expired, then the RF will come on. You can see our pressure with 75 SCCM on both nitrogen and oxygen we're right around 1 torr in pressure. RFs come on. We're sitting at 200 watts forward, about 1 watt reflective, and then we can see plasma in the chamber. You can see our time also here, RF power on at 30 seconds. We'll terminate the process. Now process is complete. We can go ahead and hit vent, and it will vent the chamber back to atmosphere. Now some of the different pages here we'll go through. Manual control would be where you could actually turn on your gas flows. You could put a set point in and turn your nitrogen gas 1 on, set point gas 2, oxygen on. You could turn your generator on, put a set point in there. Also you can plot your RF power and pressure here. When you're in mount, this here data will be also be collected in the USB thumb drive. Across the setup we've gone over to where you can edit recipes, make changes to your recipes, that sort of thing. Linearity page is where you can check the linearity and calibration of your mass flow controllers. So if you have a drifting problem, whatever, you could plot these and make sure that everything is good. Configuration screen, it's where we would put in our vent time, the size of the manometer, the size of our MFCs, size of the generator, and the forward and reflective signals. Your fault screens for your manometer, your pressure, your gas flows, and then the faults for your RF. Diagnostics control is where maintenance personnel would come in and you could actually pump the system down, you could vent the system, you could do a set point and turn your generator on. Same thing with set points on your gases. So this would be for a maintenance personnel trying to diagnose things, manually operate the system.